Hello and welcome back to Evening Rust. I'm edA-qa mort-ora-y, and today we'll be continuing our battles with rusty weapons against the evil interview questions we find online. Yesterday we did a few questions and we had lots of fun battling a string of all things. It caught us off guard, and the first thing we'll do today is we'll go back and we'll figure out what was wrong in that string, and it was thanks to one of my viewers, IKLS, that we actually managed to figure it out, and we'll look at that. And then today what we're going to do is we're going to bump it up to the medium level, not because we think we're ready for it, but because there was nothing left with graphics on the easy level. So we're going to hope something with graphics is on the medium level, and then we can program it and watch the graphics. We might have a bit harder time because my Rust is still quite rusty, and we're going to see what happens. First, what I thought today is I'd throw a few messages into the live chat, see if we can get anybody to join us. Throw the one in German because they seem to keep presenting me this channel. Only doing this because they keep presenting me this channel. And go off to English and do that as well. I'll just do that quickly and then we'll start with the show. Feel free to say hello, especially if you're coming from one of these sites. And if you have any questions or if you can help me in Rust, please do. If I don't have any help, I will be looking at the API. And I looked at this section just before the show, actually earlier today. I looked a bit about the memory management, and it's helped quite a bit to understand their ownership. When my viewers were telling me yesterday about move semantics by default, it's a bit of a shock. But now that I understand it, I know how that works. I'm familiar with that from move mechanics in C++. So we should be okay to go. So yesterday, what we had trouble in one of the practice ones in the easy rounds. Let's go there. How do I get rid of this thing now? Can't get rid of this. Okay, there it is. Well, we keep it open for a second. All right, and it was on the ASCII art question. We had a bit of a problem. I think you can just click solve it here. And this is the simplest solution I have now. So let's see what I had before. We had this ridiculous thing where a substring, or these two lines here, we're doing roster.charge.skip from is usize take 2 minus from is usize.collect. This is how we're doing a substring. And our viewers were a bit confused as to why the above didn't work. And I was too, and we found it out, and thanks to IKLS, we actually came down to the answers that this should have worked. And the clue to this, though, was what we actually had a problem with, it turns out in the end, is this console output here. It was small, and it was red. And red letters, for whatever reason, do not compress well in the video stream. They get a horrible compression rate, and you can't read it, and it's also very small. You couldn't distinguish from errors, and the actual error was seeing us sitting right in front of our eyes, and I just wasn't reading the whole thing each time. Let's hope you can still see this. Let me know if you cut off the code, but it should be okay. I'm just trying to make this window bigger, so maybe we can see more today. And so what it came down to was this little bit right here, basically, as usize. The error wasn't about us having the wrong type, wasn't about us having the wrong mutability. The error was the fact that this was an isize before, an I32 actually, and you can't do the ranges with a signed value. They have to be unsigned. And so once I changed that to when I understood that, we have this much more elegant solution where we take the row, take the substring, and print it. This is much tinier. There's no nonsense to this, and it worked. I tested it again. And hopefully won't have that same mistake again, but we can't promise that. So let's go back and let's look for our next challenge. As I said, we're done with the easy ones, not because I think I've got them all done, but because none of these have any nice output. They're all very boring. So we're going to look at medium, and we're going to basically take the first one that isn't ridiculous and has some sort of graphics. This one says plus 150, so it's probably hard. And there is no spoon. Does this have graphics? Aha! Graphics. Perfect. This is what we want. I'm hoping this one will have nice graphics to play with this. And what does it say we're testing here? it tests loops and multi-dimensional arrays. Alright, if anybody knows how to do a multi-dimensional array in Rust, please speak up, or we're going to have to fight our way through this. I could actually probably stumble through this without proper multi-dimensional arrays, but we're going to see what happens. And let's read the story first. Xeon is being attacked from everywhere. The last free humans count on you to enhance the triggering mechanism of the APU's Armored Personal Unit in order to give humanity a decisive tactical advantage. First phase, code the initialization mechanism of the APU. Alright, so there's multiple ones here. Who knows why there is no spoon? But we're just going to deal with it. We're going to start solving it and see what happens. And the community success rate is 40%. And that is foreboding with my limited Rust knowledge what we can do. Well, let's go to the solve it screen and see what happens here. And who knows what this is? What do we have to do? It's played in a rectangular grid with an even size. Some cells contain power nodes. The rest of the cells are empty. So it's some weird Pac-Man game. Okay. The goal is to find, when they exist, the horizontal and vertical neighbors of each node. Alright, we're going to have to see something. To do this, you must find each x1 coordinates containing a node and display the x2 coordinates of the next node to the right and the coordinates of the next node to the bottom within the grid. If a neighbor does not exist, you must output the coordinates -1, -1, and you lose if you give an incorrect neighbor for a node, you give the neighbors for an empty cell, you compute the same node twice, you forgot to compute the neighbors of a node. This either sounds not too hard or I'm confused on something. In this example, there's 3 nodes in 2x2 grid. The cell at 1, 1 is empty. Alright, that's 1, 1. They're starting at 0, 0. And the node at 0, 0 has 2 neighbors. So we output 3 nodes. The first node, 1, 0, 0, 1. Got it. The node at 1, 0 has no neighbors. Okay. The node at 0, 1 has no neighbors. So we output all 3 nodes. Okay. And don't forget to run the tests by launching them. I don't know why we would not do that. Okay, so there is actually different validation tests. I never even realized that before. I always thought they're the same. A debug is mode available. You can zoom on zoom. Blah, 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 blah. Okay, so what do we have? It's giving us less information than it did last time. Don't let the machines win. You are humanity's last hope, which is not good. That's not good for any of us here, if our last hope, but okay. We'll do our best. What are we supposed to do now? We're supposed to go through the whole grid? What do we have for a grid? With characters, each 0 or 1. I gotta figure out what we're actually provided in the sum here. Does it scroll down further? Did I miss something? Oh, there we are. Good. The program must first read the initialization data from the standard inputs, then provide the standard output 1 line per instruction. 1 integer width, the number of cells along x-axis, 1 integer y, the number of cells along the y-axis. Good. Next, width and height parameters. Are we reading these in today correctly? Looks okay. Note, I32. We may not want this. We may want usize, but let's stick with this for now. Next, height lines. A string containing width characters. A dot represents an empty cell. A 0 represents a cell containing a node. Let's hope there's nothing else in here, and let's just step through these things. And off chance, if nobody knows how to do a multi-dimensional array, I'm just going to do one fixed size vector. And we're going to do that assuming everything is the correct size. Let mut grid. This is a vec of probably just bool, yeah? Bool is a type, equals vec new. This is something I still don't understand in Rust. Why do I not have to put the type on the right-hand side? Why is it on the left-hand side? How does it know what type it's actually creating? In any case, so we have this line. We're going to assume it's valid. And so we're going to do for I in 0 dot dot, what is it, width? And we're going to put something on the grid. We're going to put grid vector. How do you push to a vector? Let's quickly look. Vec. What is vec? Standard vec. Probably push something. Do we have a push? Push, push. How do we push? Push. Push looks good enough to me. So let's push a value. What value do we want to push? We want to push whether it's on or not. Does it have a cell? And I need these clearer names and put it here and say let has cell. This does not need to be middle equals. I think we can use subscripts here. And okay, so line, and we have I equals 0. If it's anything else, I don't care what the input said. If it's anything else, it's going to be false. And that should be good. And now we're going to have to walk through this grid and output all the cells that have something. Actually, output something for every single cell. And we have a width. I don't care about these constraints. And load response time to first output line is less than 1 second. Okay. 2 seconds, 100 milliseconds. Well, I have no idea what you'd be doing for 100 milliseconds. Okay, so let's see. We're going to just walk through the whole grid. And I'm guessing we should do it by row. So row in 0 ... height. And they cast it to usize here. They cast it to usize here and as usize here. So let's just go back and actually make this usize. Usize. We can avoid the casting everywhere. I think the same. Then get rid of the casting. Then we don't have to deal with it. And it's unfortunate. I'm actually kind of unfortunate that you can't just use integer everywhere in Rust. And in a way, it makes sense. It's a convenience that you want to be able to do subtraction and not worry about overflow. But I think it takes care of that. I think it's meant to do an error where there's a discussion of it. And then you're forced to use unsigned because you want to say, well, there can't be negative. But that's not what we're here for right now. So let's do column in width. And then we want to see, is there a cell here? And I guess if there's no cell here, we don't emit anything. I read that again. Output, 1 line per node. If there is no neighbor, what if there's no node? If there's no node, do we output anything? This is a bit ambiguous. You give the neighbors for an empty cell, okay? So, if not grid, and this is where I mean I'm not going to actually do multi-dimensional arrays. I'm going to do height times width plus column. Row times width. We'll manually do the multi-dimensional array, and we can look this up later. And does anybody know does continue work? Is it the standard keyword? Let's hope that it is. Okay, and so now we can output just this one line. But we can calculate all the arrays at once and then output them all at once. So what we need to do is we need to do a print line for this cell. And what format does it want? Okay, do you think it wants them in the little braces? Okay, it's a bit unclear on whether we want braces or not. So let's assume not. So we're just going to have this, where it's just probably going to be a list of numbers. And then there's the second set of numbers, second set of numbers. And the first one here is going to be column, comma, row. And then we're going to do what neighbor? Right column, right row. And then we'll do bottom column, bottom row. Okay. And what we have to check now is, so does the right one have a cell or not? Let's just initialize all these variables first, and these are all going to be isize, whatever they are. Let mut our column. Let's just initialize them all to -1, or no, let's initialize them to the value they should be. So the rightmost column is going to be column plus 1, and I'm going to get sizing errors here, I know it. It's going to be the wrong type. And our row isize equals, well, it's going to be the same row. We don't have to change that. And mut b column isize is going to be the same as the column. And these are the next cells, B row, isize equals row plus 1. Okay, and that should be enough to output something. And if I run this now, I'm pretty much assume it's going to fail. We wrote everything we needed to, but it's going to fail on us. Because we're not checking to see if it's valid or not. But let's just see what it says first. Let's check what our compilation errors are first, and as always, so this is what we complained about. Oh, it's still in red. I chose the higher scheme, but hopefully you can see it better. Index. We can't index. It's not indexed. So what do we want? We can't index this. What might we have? Characters I? Mismatch types, isize row. Okay, this is clear. I'm going to have to do this, convert them all back to size. And this is one of the things I don't like about not being able to use an integer everywhere. This actually bugs me a lot in C++ as well, is that you have the size t and SS size t, and you have to keep converting back, and it's really a pain. And if you're dealing with indexes, I actually think an assigned value is the correct natural type, and your constraint checking should be done a different way. Okay, what error do we have now? Unnecessary parentheses. I don't care about those warnings. I'm trying to be consistent. It's probably complaining about these things here. Line 46, it is, or 48. Okay, I'm not concerned about that. 34. Okay, it looks like they actually do jump around. It's just not for Rust. It's not parsing the Rust correctly. 34. So we're into our first actual Rust problem. Is I need to know how to get the character at that string, and I thought we handled that before. Pretty sure we did that yesterday, how to get the character out of the string, and just why isn't it working? Cannot index into a value of type standard chars. Okay, how do I get the character of a string? Let me check my cheat sheet if we have any reference for that. Chars from to.collect. So we collected a whole substring there, but in another one we must have done something else. Okay, so we have the chars is probably correct, but how do we get the string? And this is not something I think I can easily look up, but let's check string first. This is it a string type or a str? We have an actual string. Okay, it's an actual string. And let's look at the actual string. Str being I think the literal string. And what functions do I have here? Well, this isn't what I want. Can I get a character from a string? Add, retain, pop, remove, adds, byte, shrink, clear, drain, splice, into. You think there'd be like just at least one function to get a character from a string? So we're going to resort to searching for this. Let's see what happens. Get character from string in Rust. That's really, I think, what's missing right now. Getting a single character string, Stack Overflow. It's strange when you search for Stack Overflow, you can find answers. But if you ever ask anything, the chance of getting answers is pretty low. I just do this. And there's a character at function. Oh, that's a stir function. Characters nth. Nth. Stir get. Okay, Nickers, what does stir get do? Really just, does it get me a string? I'm going to try it. Now, line is a string, it's not a stir. I always still getting confused on this. Stir is the literal string, but let's try get. Where's my error? Slice index stir. Slice indices are of type usize. So what do we have here? I is, yeah, just call it usize. Alright, what is it complaining about now? We have, man, this window here is terrible. The trait bound usize at 34 is not okay, zoom this in, is not what? Is not satisfied. Standard slice user. Slices are of type usize or ranges of usize. Okay, now I'm getting confused. Is that not what we have? Do we not have an I as usize here? Slices are of, okay, its indexing is clearly wrong. Get I'm going to try the other syntax we saw, or is it characters get, or maybe nth. Try this one. We'll get something else now. Unexpected enum. Oh yeah, okay. This is this weirdness with unwrap. It's actually returning a wrapped error value, and we have to get the value out. And this, I believe, panics if we don't have it, which I suppose is good. And all right, well, we got something. We didn't get an error. We got an invalid node, and that's exactly what I said we'd get, because we didn't actually do the checking. But I want to see what it looks like on the screen. Does it show something on the screen? It's so system failure. Well, that wasn't too exciting. All right, so we read it and we've got the handle here. I've got lots of shifting between size and usize. And just have to remember in Rust, anytime you do indexing into an array or range, it looks like it has to be an unsigned value. And I honestly don't know why this can't be right. This can't be a usize because it should be a usize. No, 0.width. All right, so that's correct. I'm glad I don't need that because this I should be a usize because width is a usize. So now we actually have to check. What we want to do is if this column isn't valid, then we switch it to -1. So if our column is greater than or equal to width or grid, our row times width plus our column, or not, then we set them both to 1. Our col equals our row equals -1. And we do the same down here. If the column we don't have to worry about now is the b row is greater than or equal to height, or not grid, b row times width plus b column. We should actually make a wrapper function to make this clear, but it's so simple I don't really want to do it yet. Maybe one of these macro things, but it's like so much to pass and I don't have classes yet. I'm going to have to learn classes and our own types later. I hope there's functions. I hope there's actually tests that come up that don't let me solve it in such a simple fashion. What do we get? We get a compilation error. The whole bunch of warnings. Come on, match types. Oh, of course. isize. What are these things now? Our call is isize. And I have dreams about casting to rsize and isize. Expected blah found width. Where does it find that? On line 47. What? Oh. Sorry, I guess I reverted to C syntax. Guess we can't use that. We'll use the Rust syntax as, or the C# syntax for conversion. And we still get an error. What one do we get now? Mismatch. Oh, come on. Give me a break. Again, this is one of the reasons I don't, this annoys me in C++ is a lot as well. When you're dealing with signed and unsigned types, and logically you have an integer, you should just use an integer. I mean, the continual conversion back and forth. And what you'll see is you'll have a lot of code like this. When forced to do it this way, you're not actually improving safety because people are just going to stick as usize. And if this is a negative here, oh well, we've just screwed it up. And I can guarantee you there's very little code that checks this. And because when you know you're logically here, I'm dealing with an integer, it's just too inconvenient to actually try and keep track with clamping and range check operations. And I'm willing to have yet another one. And I can't multiply them either. How can I simplify this? Okay, we're going to go back to here. And I'm going to try and simplify this all to use isize, and only in the very worst parts convert to usize. But this is still going to be everywhere. Okay, I don't care. That's everywhere. Row width as usize. As usize, and this one I don't have to change. But I think this will reduce the casting overall, so we'll stick with the signed values until we actually get to a situation that Rust actually requires an unsigned value, and then we're going to blindly cast it because we don't really have another option here, or anyone that makes sense as far as I can tell. Okay, let's cast that to usize and see what happens here. 1 must be wrong. Mismatch types are row equals -1. Yeah, isize. Expected isize found. Can you not do this in Rust? Let's find out. Maybe you can't. I'm not terribly upset if you can't. I was just hoping you could. It doesn't save a lot of work in most cases. It played, and alright, it worked. Weapons are online. We got this one working. Let's try the next one and make this one bigger. Uh-oh, something failed. What failed this time? We're at 0, 0, and the right was expected 2, 0. Well, that doesn't seem right. Their expected value. Okay, obviously we've done something wrong, but their expected value seems wrong. If I'm at 0, 0, to the right should be 1, 0. Well, let's figure out why I have negative here first of all, and then we'll move on to figure out what their expected value is. And I'm going to work through this logically first of all. Our grid, do we have a grid row times width plus column? That should be fine. Width is isize. Let's just debug all the information here. Print, what do they call the macro? Print air. Air, we're going to do this times height. So we'll do width by height. And for each row, we'll just say what we have here. This comma this equals this row comma column equals. I'm just going to copy this for now. And let's try this one again. Print air. These are macros. They also have to be spelled correctly. Let's try that again. Okay, standard airstream. It's a 5x1 grid. It only shows 3 up there. That's fine. 0, 0 is true. 0, 1 is false. I get it. This is the rightmost one. They don't mean to check if the next one's empty. I think they mean to check we find the closest one to the right. Let's read this again to make sure. goals when they exist the horizontal and vertical neighbors of each node. Okay. The next row to the right. Okay, so I misunderstood that. That's the reason why that's not working. And we're probably going to have to clean this up a bit here because this is clearly not... We're going to want... Yeah, ideally I like to stick this all in a class, but I think that's more effort than it's worth. So what we're going to do is we're going to find in here okay, we're gonna do yeah, we're gonna just walk through it. We're gonna walk through it. We're at this is the location we want to be at, and we want to look at each next one and find the one that is available there. And how do we want to do this? Okay, well, let's just do it this way. While our column is less than width. And not grid. We're going to say our column plus plus. Okay. Then we say if our column is greater than or equal to width, then we set it to -1. Then we do the same thing down here. We convert it to a while loop instead. While row is less than height, and there's nothing in the grid, and not grid. Then we do b row plus plus. If b row is greater than or equal to height. So basically we walk around in each direction, and instead, I would ideally like to have a class here because I'd like to make these functions on it, but this would involve a lot of setup to pass this data into there so you actually have an actual matrix. So if we can get away with this, we should be fine. Expression found. Okay. I guess this isn't supported. That's fine. Structs can implement traits. Okay. No classes, structs, and structs can implement traits. That sounds reasonable. I mean, I guess a trait would be have next, get next cell. And I'm hoping at some point we actually have to look at that. I wonder if I could hope if the template has one. And then we could do it. However it represents... Okay, so that worked this time. All connections valid. Let's just play all the test cases and see what happens. Weapons online. Online. I can't really tell what the graphics are doing, but whatever. It hasn't confused us yet. We're doing well. What is this? That's a different layout. We're online, okay. Do we have any left? Or is that all of them? We've got all of them. Okay, so we got some graphics. Got them all online. Since it's simple enough, I'm going to avoid using a struct still. As much as I'd like to learn them, I don't have the need, and we're going to try and do this the minimal way, just to not introduce too much at one time. So let's just submit this one and move on. And hope we have another one with graphics. Otherwise, we might have to go back to those easy ones. But let's try one with graphics first. And achievement, 100%. I wonder how you even get 40% on that one, because the community average is 40%. Ah, it's an average score. Okay. So we have all this other stuff. Achievement. We're now a Rust lover. Oh, that was 2 days ago. I thought we cleared these. Go away. It's level 6, so let's go back to practice again. What do we have now? Easy puzzles we don't want to do. Good, there's lots of medium ones. SkyNet Revolution, BFS, and graphs. This sounds like something we're going to need structs for. Should we try it? Alright, let's just try it. Only if it has graphics. No graphics, we're not doing it. It has graphics, okay. So it's a tree, and it's a graph. In this puzzle, you will learn to store data in a graph data structure. Searching through and updating the graph you've created will help you get trips get grips with graph theory. And there's external resources, probably none of them on actually Rust graphs. This problem plays out on a graph where a virus moves from node to node in search of an exit. This graph looks like it's drawing Mickey Mouse, but okay, there are several exits, and you have to cut off axes by finding the best link to cut each turn. Okay, Sikea. You seem to be excited about graphs, so we're going to rely on you entirely to give us our Rust structure here. Alright, our story is the virus from the resistance is spreading through the SkyNet network, but SkyNet is sending its agents to fight back, preventing SkyNet from destroying the virus by severing the right network links. Alright, let's go solve it. Success rate is 53%, even though it sounds harder. We've got lots of stuff here. There's more story, more story. Alright, let's read the story again. Los Angeles, 2029. Resistance Headquarters. Review of facts. Last Saturday, hundreds of brave fighters risked their lives to destroy SkyNet. Stop. Using contaminated Moto terminators, they managed to inoculate a lethal virus to SkyNet. Stop. Problem. SkyNet is fighting back. Stop. John, once more, we need your help. Stop. So apparently in the year 2029, SkyNet has taken over, the world's fallen over, everything's driven by machines, but we're still using telegraphs to send our messages. I guess we can live with that. I mean, the robot revolution comes, we'll break out the old telegraph lines and start saying stop for during dictation. You don't actually send the stop on the signal, usually you would communicate it, but let's go with it. So we have a backdoor. I think we have enough story. For each test, you're given a map of the network, the position of the exit gateways, the starting position of the SkyNet agent. Nodes can only be connected up to a single gateway. Okay. So we have disconnected networks. That seems a bit weird. For each game, first off, you sever one of the given links in the network. Then the SkyNet agent moves from one node to another accessible node. Victory occasions. The SkyNet agent cannot reach an exit gateway. So, text representation of the input. The network used in this example, there are 4 nodes, 4 links, and 1 gateway. Okay. The next 4 lines describe the links. 0 to 1, 0 to 2, 1 to 3, 2 to 3. These are bidirectional. The last integer is the index of the exit node. So 3 is the exit node. That sounds okay. SkyNet agent starts at node 0. I guess it always does. Our virus cut the link between the nodes 1 and 3. Cuts that off. Great. The SkyNet agent moves to node 2. Our virus cuts the link between nodes 2 and 3. And the SkyNet agent has been cut off from the exit. We have 1. So do we just cut the nodes to the exits? I guess so. The tests provided are similar to validations used to compute the final score, but remain different. The program must first read the initialization data from the standard input. Then within an infinite loop, do we have to use an infinite loop? Read the data from the standard input related to the current state of SkyNet agent and provide to the standard output the next instruction. Okay. Number of lines. Links, okay, we already have that. 2 links. The index of the gateway. Per turn. The index of the node on which SkyNet agent is positioned this turn. Okay. A single line comprised 2 integers, C1 and C new, separated by space. These are the nodes we wish to sever the link between. Okay. So, in terms of difficulty, from the ones we've done before, this has certainly taken a bit of a jump up. This requires some actual logic, I think, and actual thinking of the graph. And they said breadth first search. Maybe, maybe not. And I don't care about the constraints. 150 milliseconds, that's fine. So what we need to do is we need to figure out which node to sever. And I guess we have to check I think we actually have a cheating way to do this. I don't know if it's cheating. We don't have to find the optimal solution. We can always just check the next nodes beside the SkyNet one. and just sever any one of them. The only case we have to worry about special is one of them is an exit node. We have to sever the exit node. But I think we only have to do that as once it's right at the end. And I'm not clear in this thing about how many exit nodes. There's one gateway, and so we're going to have to cut it off to the gateways. The only fear I have is that if it's if there's multiple gateways and it somehow reaches 2 at the same time, the option there we could have is that if none of the next nodes, the nodes besides SkyNet, have a gateway on them, we go and find a gateway and sever one of its nodes. And that would prepare us for the path that SkyNet's taking. And I think what they want with they mentioned breadth first search is ideally what I do here, if you wanted the optimal solution, you would use probably a A-star algorithm. And the A-star algorithm would be from the SkyNet node, what's the closest gateway node, and sever the path to that closest gateway node. Okay, now we need to read this stuff in. We need to have a structure of, again, I can cheat again here and use a matrix. We have lots of memory, I hope. So I'm going to use a sparse matrix well, not sparse matrix, I'm going to just use a simple matrix. There's at most 500 nodes, which means our matrix would be 500 by 500. That's totally within reason. It's 150 milliseconds. I'm assuming Rust is compiled. It's not running in a virtual machine. This should be more than enough to scan 500 nodes. So let's do the really cheap way. We're not going to have an actual graph. Well, we have an actual graph, but we'll use a matrix representation. We won't use a link. We won't use structures. And so we can avoid using structures once again and just have a big matrix. I think it would be nicer to have structures, but boy, do we really want to do that? Okay, yeah, let's try it that way. Unless somebody wants to quickly type up a struct, or does anybody care to do a struct? Actually, you know, all right, let's try it without first. If I get confused and we're getting errors, then we'll go into the structure form. But what I mean is the structure form is we should abstract this. I'm going to do the exact same thing again. I'm going to have a this is the graph. And it's a vector of each cell needs to have one of 3 values. We can say 0 is there's no connection, 1 is there connection, and each cell also, no, you only need true or false. Then we need to know which one is the exit node. And we can have a separate list of exit nodes, I guess. The number of exit gateways. We can put these here. It's not a wonderful way to do this, and Rust enums. Are they different than normal enums? So you're saying an enum would be better than a bool here? Because I just said I need 3 traits, but I'm down to 2, so I'm tempted not to have an enum. Because I realize the gateways have to have multiple things, so I'm going to put them in a different one. Are enums like the cnums? They're just take a list of values and do 3 of them. Okay, and these are all I32 again, just to annoy me. This is I32. And so what this has, when we do a new vector, can we initialize it somehow? That's the one thing we will look up. I want to initialize this to a whole set of false values. Anybody know how to do that? They're like safe unions. That's enum. Okay. Makes sense. I'll look those up. I don't think I need them right now. Because I'm not storing the cells. I'm storing them in 2 separate lists. Okay. Do we know how to initialize a vector filled with 1 value? Rust fill vec with value. How to make a vector of received size, collect. That looks weird. Let's see what that is. Creating a vector of 0, that sounds more like what I want. I would just say yes. Upvote that. No, there's got to be an easier way than that. Alright, let's try the other one. The recommended way of doing this fact an iterator and collect it to a vector. What you want to do is not precisely clear. However, if you want blah blah, you would create a range and collect it to a vector. But this is going to have a bunch of standard iter repeat. This sounds good. Oh, that works. Oh, that sounds even better. Thank you, Sakia. Because this one looks weird. I guess this is a short form. We're going to do it that way then. We just do it right here. Vec. This is its macro form. So that must expand to it. And we want the value false. And we want n times n. And that'll fill it up with false for us. And then we'll do graph and 1 times n plus n2 was true. Is it clear what I'm doing here? What this is a graph is all the nodes along the top and along the side, and if there's a connection between two nodes, I'm going to stick a true value in there. And this has to be both ways because it's bidirectional, and so I'm going to do it both ways. And 2 times n plus n1. And so this creates a graph of connections. So when we have a given node, it's easy to find which ones it connects to. And when we break a connection, we have to set both of them false. And this is where I mean this would make a lot of sense to have, as Nika says, probably a structure and whatever traits are, I don't know what those are, and because then you would abstract this out to breaking and setting a connection, so you'd have an abstract graph class. And for the graphs, we can actually, for the gateways, we can do a simple list. Gateways vec of, and this is now I32 or isize, doesn't matter. New. And we'll do gateways dot push EI. So now we have a graph of our input, and for each of the inputs, what I'm going to do is we're going to take my brain dead approach and say, if any of the nodes beside the current SkyNet index is the gateway, we break that link. If it's not, then, well, we should break some other link. All right? So at the SkyNet node, this is how we check if there's a gateway link. We're going to say for I in 0 dot dot n, and we check all the nodes. If not, graph. Alright, so we have si times n. And this is the index into the multidimensional array because, again, I failed to look up a multidimensional arrays. And we're going to say the actual node if these two have a connection. And so if you had multidimensional arrays, this would be something like SIN or SII, right? And we're just doing it manually because the width of n. And so we're saying if there's not a connection here, let's just continue. There's nothing of interest here. And we're going to say we're going to track gn equals -1 size again. And so we don't find it if we find something. So now we say there is a node. But we're going to say if, now we have to find it. Is there a quick way to find a value in a vector? There must be. Can't believe there wouldn't be. Must be a find. Find, come on, find. Find, resize, find. Oh, there is no native multi-image arrays. I feel so much better that I'm doing it on my own then. Okay, is there a way to find a value in a vector though? Not binary search, Just normals, contains. Contains sounds positive. Contains T. Alright, good. Hopefully that works. If not, gateways dot contains from slices. Okay. I'm slowly understanding the slices. So this is a slice function. So if gateways does not contain, it contains the, what are we looking for? I. Then we just move on. Then we continue. We're also going to do this if SI equals I would continue. I'm making these all as distinct conditions so we can very clearly see what it is. Skip SkyNet node. Skip nodes without a link. This sounds very helpful. On the upper right of... That is much nicer. Thank you. This left-hand search I wasn't doing so well, but this I can deal with a bit better. And then we can expand them as needed. Yeah, I'm gonna like that. Thank you. So, prefer gateway. And to avoid doing this loop twice, let's just look for some other node as well. Let other node equals -1 isize. This should never become -1. So we're going to say if gateway contains I, then we're going to say gn equals I. We want to break the connection to this one. Else we want to break the connection to the other one. on equals I. We're going to track another node just in case there is no gateway node. We're going to break it anyways. And so now we have to break the nodes we want to break. The link. And because this is suboptimal, it's always going to be where the SkyNet node is and some link it's connected to. And this is going to be, how do you say it? If gn does not equal -1, gn else on. I wonder if it's going to whine at me for on. Is there some reserved keyword called on? It's a bit dangerous using that, but let's find out. Well, first of all, let's find out all the errors I've made. Okay, perfect. Unused macro definitions seems like an entirely unuseful warning. They must have like super warning level turned on or something. So let's maximize this again. Mismatch types. Of course it's a mismatch type. It's always mismatch types. Okay. As usize. As usize. Blah 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 blah. As usize. And I'll just assume all the other ones were also type errors. Expected use. I hope it looks better with somebody else doing it. Okay, and this is what I could actually complain about. For a highly typed language, integers, n times n cannot be negative, so it should automatically be a usize. But okay, let's just try not to complain about that too much. Expected isize found I32. Well, that's easy to fix. These all become isize. And this is actually a bit surprising to me. Trying to think why. I want to think it was, why can't I push EI here? Presumably an I32 can be represented as an isize. An isize is going to be at least that big. I presume it's an I64 actually. So why could we not convert the I32? If I ignore the special rules for fundamentals, this is probably a move This is a typical move instruction. So if I were moving this, it would make perfect sense that I can't move an I32 to an I64, to an isize. However, there's special rules for fundamentals that it's supposed to copy, so maybe there's something I don't understand here. It probably has to do with vector being generic, that it's not going to do conversions. And so it requires the exact type because it's doing a move instead of a copy. So if I convert them all to isize, that's fine. And let's try it again. Your program did not provide an input in due time. Uh-oh. No, it's an airstream. Ah. Found built-in type usize. Alright. You can't multiply by usize. You have to do as usize. That makes perfect sense. And it's weird that their output doesn't detect I haven't compiled. It just keeps running and says, look, it took too long. It's just weird. Gateway contains I expected I and size found. Blah. 66 contains I. For I and 0 to n contains I at. What is n? N is an I size. Gateway is an I size. Okay, yeah, got it. So these vectors. I'm used to both C# and C++ in this regards, that if I think strictly in what I read in Rust here is that if I think of how the vector is implemented, this contains function is going to want to take a reference. And this makes perfect sense because when you look for contains, you don't want to copy the object. It's just when I'm using something like a fundamental type, I'm expecting a copy, but Rust apparently never takes a reference automatically. And this is something I thought a lot about in Leaf. Whether the caller should explicitly have to say a reference is taken, and there's a lot of positive reasons to do this because in C++ and C# and Java and Python, in all these languages, when you say call something like contains, this function can modify that value, assuming this was a structure or something and not a little I. And so this is kind of a positive step. It adds syntax overhead, but in a way it says, look, you have to be aware of the fact it can modify it, or not modify, but it takes a reference. And it can't modify it because it's not immutable. So it's a bit safer, but in this sense, yeah, if it's not mutable, yeah, I don't know if it adds much. But I'm starting to understand the logic behind this. And it's one of the reasons why I'm looking at Rust is because they do have this very different view on things. And obviously as a language writer, it's very important that I understand these other views on things. I can't ignore that they have a solution here. Oh, I forgot to show the graphics. But our stupid approach at least worked on the simple one. So let's show, can I get this, let's make this really tiny now. Let's play the second test case. Yay! We destroyed it. Okay. So let's play all the test cases. Oh, go away. It appears to be working. We've actually managed to save humanity, I believe. We've saved humanity with my very limited Rust skills in a very suboptimal. Yay! And now I must say this is not really an inefficient solution. Because there's absolutely tons of graph work you want to do this way, it depends on the sparsity of this graph. If I had like thousands of nodes, you certainly do not want to hold the graph in a matrix. But it's set up to 500, and I say I usually ignore this, and 500 is really fast. And 500 is actually to the point that this may actually be far faster than an approach that uses links, like actual high-level references. Because of the fact that skipping random access to memory is really slow, scanning this graph in this linear fashion is actually extremely fast on a CPU. And because Rust is compiling very low, this is going to be a very tight loop on the CPU, and it's going to have one block of memory, and it's quite possibly something like this. That's only like, each one of these loops could be evaluated with the branch prediction stuff in 5 to 10 cycles. And so 5 to 10 cycles times 500 is really nothing. And if you had an actual memory reference, it could be longer, because it has to load memory. Just want to remember. Let's submit that. Great. What? Just one achievement? I'm used to more. Ah, there we go. And we've leveled up. Here we go again. We've leveled up. Let's let everybody know we've leveled up. I want to go back to get my Twitch link. See if anybody wants to join us in our great escapades here. I just leveled up in Coding Game live at... There we go. Let's send this off in Twitter. Good. Who knows what happens there? I'll check the format of that later. Something looks suspicious there, but nonetheless, let's go to the next step. Clear the notifications. We appear to get 3 notifications for each one, and we're an apprentice. We'll clear that off. Let's find out what we have next in practice here. Shall we do one of the classic ones? No, these mediums are easy enough. Panic. Panic. Don't panic. This sounds like a very good thing to do in Rust, not to panic. We haven't panicked so far, so let's see if we can continue not panicking. And there are graphics. Great. So let's not panic. Hey, I recognize this guy. Where is he from? Anybody remember what this guy looks like? Okay, in any case, let's go... Marvin. Ah, it says Marvin. Marvin is stuck inside the core of an infinite improbability drive. Grab your towel and help him, or them, escape by blocking the right clones to allow others to reach the exit by going through the right happy vertical people transporters. This is also part of a 2-puzzle one in Don't Panic, so this is Hitchhiker's Guide. That, now I get the reference. Where's my big red button? Alright, I don't want it. You'll learn to position an object on a one-dimensional grid. Now, a one-dimensional grid doesn't sound like that exciting, but okay. Coming where from, this is less experience. The other one was 150. This one gives us less. So let's solve this. It has graphics. And, oh man, look at all of these values it has. And each, wow, they just keep giving us values, values, and values, and values. Okay. I need to reach an exit. The drive has a rectangular shape of variable size. It is composed of several floors. 0 equals lower floor. And each floor has several possible positions that clones can occupy. 0 is leftmost, width -1 is rightmost position. The goal is to save at least one clone in a limited amount of rounds. Poor clones, we're only going to save one of them. Clones appear from a unique generator at regular intervals. Every 3 game turns. The generator is located on floor 0. Clones exit generator heading towards the right. Perfect. Clones move 1 position per turn in a straight line, moving in their current direction. A clone is destroyed by a laser if it goes below position 0 or beyond position width -1. Seems fair. Maybe we should just destroy them all and see what happens, just to make sure we can see that graphic, or it's probably happened on its own. Elevators are scattered throughout the drive and can be used to move from one floor to the one above it. When a clone arrives in the location of an elevator, it moves up 1 floor. Moving up 1 floor takes 1 game turn. On the next turn, the clone continues to move in the direction it had before moving upward. On each game turn, you can either block the leading clone, meaning the one that got out of the earliest, or do nothing. Okay, this is starting to sound like Lemmings. Once a clone is blocked, you can no longer act on it. The next clone in line takes the role of leading clone and can be blocked at a later time. When a clone moves towards a blocked one, it changes direction from left to right or right to left. It also changes direction when getting out of the generator directly on a blocked clone or when going up an elevator and into a blocked clone. If a clone is blocked in front of an elevator, the elevator can no longer be used. When a clone reaches the location of the exit, it is saved and disappears from the area. For this puzzle, there is at most one elevator per floor. So this sounds very much like Lemmings, and the elevators only go up. I hope. Number of floors in the area. A floor moved from 0 the width of the area. The maximum number of rounds before the game ended the game. We've never gotten that before. The floor in which the exit is located. The position of the exit on its floor. The total number of clones will come into the generator during the game. Number of additional elevators not used for the first question. Value is always 0. So we have one elevator. Number of elevators in the area. And we have one per floor, it said. Elevator floor, elevator position, where all the elevators are. And one direction of the coordinates leading. Right now I'm trying to think very visually. Integers clone floor, clone position, and one string direction, clone floor, clone position are the coordinates of the leading unblocked clone. Direction indicates the current direction of the leading clone. If there is no leading clone, the line values are -1, -1, none. This can only happen when the clones, which are already outside, are all blocked, and the next one is not out yet, in which case you may output action wait. Ugh. Okay. And I only have two things, wait or block. Wait or block. Alright, this one sounds slightly more difficult. Now I'm trying to think how I do this. If we would assume okay, we're going to have to assume that the elevators are not on the 0 in width -1 position because we'd have no chance to block a Lemming, a Marvin, on the other side of it. So if it weren't for time, we could actually do this stupidest and cheapest option of as soon as a robot reaches the endmost position, either side, we block it then. And let's see how far that gets us. Let's see how far the simple solution works. Ignore all of this stuff. All we need to know is where is the clone's current position. And then we can do this if clone position equals 0 or clone position... Oh. We need to know which direction he's going, because if he starts at 0, let's worry about that when it happens. Where's our width? Width -1. Then we block. And I'll be disappointed if this works, actually. Oh, there's graphics. Come back, graphics. Well, it worked for the first one. The number that are coming out might be an issue. Well, let's try the second one. And he's going to block there. Good. Alright. Please don't tell me we can solve it this way. Let's try another one. Let's make this really big to see this other one fail. Alright, good. We want this one to fail. Guys, it's not failing. Alright, let's just play them all. Let's see which one it fails on. I like winning. It'll work on this one. Why did we skip that one? Okay, we're going to run out of time on this one. So we're going to have to be a bit more clever than I was. We're going to have to stop them earlier. And so they clearly did this level to block our stupid approach. But how far did we get? We got 5 of the test cases done on the simplest approach you can possibly imagine. And what we really need to know then is, if you look at this graphic here, hey, get back here. We need to just stop him here. As soon as he's here, we stop it. Uh-oh. My machine's overheating for some reason. I gotta kill something else here. Something's causing my machine to overheat. Just a second. We're gonna do some sensors here. My, oh my, oh my. This little thing here is using way too much energy. Does it go away if I do that? This is really bad. Web content. Yay. Uh-oh. Guys, I don't know what to do about this. This little dialogue here is causing way too much energy to be used. And just a second, I'm going to kick my fan and see if it's causing some problems. I'm going to pause, go to away for... Now I have a bit of an issue. I don't know how to do this one right now. I think we're going to have to come back to this one. I'm going to have to do something without graphics for it because this is really weird. This thing is using 100% and I don't know why my machine's overheating. I've had troubles with the fans before, but you can clearly see I have total CPU use is up to 260% on a 4-core machine. And yeah, I can't actually do that, and I'm just barely touching it. You can see I'm at 88. Pwah. And I've been meaning to get a new machine for that reason. I'm going to freeze myself out. Just a second, I can freeze myself out. It should help a little bit. It's winter, and this was actually supposed to be a quiet machine, and the machine's on full, and it's the fan. I have to clear out the fan again. It's a bit too noisy. If I lower the temperature a little bit, we might be able to get away with it. Let me know if it gets too noisy. And okay, so now back to the question at hand, and if you hear the weird beeping, we will have to do another one. And the CPU can actually withhold the temperature it's at, but the alarm is at 90 degrees to prevent it from going higher. It could actually go all the way up to 100 and something, but it usually doesn't get there. But the alarm is just kind of nice. And okay, I say that. Honestly, I just couldn't figure out how to get the BIOS to save an alarm that's higher than that. It just kept reverting it. All right. So back to the question at hand. We have... When we have this little thing here, oh come on, let me see it. We want to stop the guy as soon as he's here. And so we need to know the locations of the elevators, each one. As soon as he's walking away from the elevator, as soon as the guy's like walking away from the elevator, then we're just going to block him. And the way we can do that is, how do we do that? Well, first of all, we're probably going to have to save this information. What does it have in here? For each elevator, has a floor and a position. Each floor has only one elevator, so let's create a vector again of these. Let mut, let's just call it elevator, positions. How do I want to shorten this? Elevator positions. You know what? I don't care. Elevator positions. Let's make it nice and long. This is a vector of, these were I32, that's fine, equals vec new. And these start at 0. No. Are these actually out of order? Did it say what we had to do? Oh, that's mean again. How do we do that? Vec. We want to create, just start them all at 0 of the right size, and there are exactly how many floors? NB floors. And oh, I think I got it in advance this time to cast at usize. And so what we can do is we can just say elevator positions, elevator position. Just make these both usize. No, I want this one I32. isize. isize is what I want. Elevator position equals elevator floor. It's per floor we have a position, and we want to say elevator position. So on each floor we have a position. Now I have to actually understand the logic here. I got through really 5 rounds without really knowing much about this. Direction. Is he going left or right? And so let's take the simple case. They said if the clone has no position, if clone position, what does it say, -1? Then we'll take our shortcut, print line wait. Continue. And this will be our shortcut. I don't want to deal with the rest of the logic. I always have shortcuts like this so that we don't have to deal with special cases later. And we're going to block. If he's at the end, we're going to block. And I'm going to leave this in as a special case. Just in case I failed to mention some weird case they have, he always blocks at the end, and we're not, if he ever gets there, there's no loss of optimality by letting him block there. And what do we want to do now? We want to say if he's moving away from the elevator, he should block. And so direction, left or right. So how do I want to convert moving away from the elevator? Alright, let's just take the simple thing. If. Actually, let's get the elevator position first. Vars from leaf. Let's e position equals elevator positions of clone floor. And I'm going to directly convert this to an isize, usize, parse it directly, and clone floor. So we have the position. If the E position is less than, I know what error this is going to cause, but we're going to fix it later. He's going to stop right on top of an elevator. So we're going to have another condition, but let me show you what that's going to look like first. If the elevator position is less than the clone position, and direction equals right, then we print line, then we block him. So if he's moving away from the elevator, now I'm going to put both conditions in one, and we're just going to continue. In all other cases, we're just going to wait. So I need a big or here. Or, and Rust, I think let's continue lines. E position is greater than the clone position, and direction equals left. All right, let's scroll back up and make this a bit smaller. and see what happens. Uh-oh, I made an error. Let's see what happens. Elevator positions. Oh god, I spelled it wrong. Line 63. And E position found. What doesn't it like here? Oh yeah, sorry. Or elevator positions is line 40. Does a double click work yet? No. They should really fix that. Coding game, if you're watching this, can you please fix it so I can click on the air here and get to the line here rather than jumping back to the top? Elevator positions. Let's see if that works. Okay, what we have is expected isize found I32. Oh, of course. Let's just do isize. Come on, leave me alone. Just do isize then, not I31. Oh, we're doing something. Get back here. Get back here. What are we doing? Oh, it doesn't block them in the elevator. They still go up and change directions. That seems good. I hope you can see this. This looks like the optimal solution here. Ah, no. Ah. There's one more at the very top. They're going to have to move directly to the exit, it appears. Do we have that information? Well, we better have that information, otherwise we're in trouble. Exit floor, exit position. You know what? Our logic doesn't change. Elevator positions, exit floor. And we're going to make this a usize. Exit floor is a usize. And exit position is a isize. Our logic should be exactly the same here. Equals exit position. We just treat it as an elevator. We don't care that it's the exit. And we have a speed thing here. Make this go a little bit faster, double the speed here. High quality makes no difference, it looks like, so. Alright, that worked. He still looks sad when he wins, but okay. And what do we have? We have one more. I can't tell the name of it, but let's see what that one does. I won, I guess that's the previous one. Alright, it's just testing our logic. Alright, we won. He's Marvin. Yay! Alright, so this was, assuming the other ones still work, this was surprisingly easier to do than I might have expected. The logic isn't too advanced. What I was worrying about, and if I show you the screen again and go away, what I was worrying about is when he stops right on the top of this, does that screw up the Marvin coming up? Does he go back down the other or something? But he doesn't. So we're totally okay here. And we're going to blindly submit the rest and assume that the changes I made work just fine. Oh! Oh. Uh-oh. No. We did something wrong. We should have checked it. Guys, we screwed up. Alright, can I go back and... No, go back. We gotta fix this. It's not okay. So our blocking case has a special case that has to be fixed. Keeps the same code, so play this test case. What's he doing? It's a panic error. Invalid digit. Do we know where this failed? Okay, we have some error here. What type of error could we possibly have? Oh, shit, I know. We cannot parse these as usize because they could be -1. And so the clone floor, wherever I carry this, they're going to be -1 here. And it said they're both -1, so we only need to check one. I win! It's a bit inefficient, but that's okay. Let's just play them all. Let's play them all very quickly. You know, for something that's using over 100% of my CPU, it's getting a very low frame rate at 14 or 18. Yay for HTML5 apps. Oh well. It produces pretty graphics. What else do I care about? Guess not overheating is nice. We're doing okay now with the overheating. That's all of them? Okay, let's submit this now. So that minor error, parsing as an isize, and that's fine. Let's just submit it. We have a blemish on our record now. We got one. We went up another level again. We only solved one more. I'm not going to tweet this one again, or because I don't know how much I'm going to keep coding today. So next step. What do we have here? We have achievement. Don't panic. Achievement, achievement, achievement. All right. Should we try to finish off with one of the easy ones? It's got no graphics, but we could use something quick today to finish off with, and mime type doesn't sound exciting. Horse racing duels sounds a little bit harder, but it'd be nice to finish with graphics. Or should we just finish with this? Mars Lander 2, I know it's going to be harder. Let's just do one of the... Let's do one of the classic ones to finish off with. We have the 2 with graphics. We're going to have to finish it that way. Let's hope this one's simple to solve. There's no graphics, but let's hope it doesn't take very long. And look, there's nothing to even scroll. And the goal, Casablanca's Hippodrome is organizing a new type of horse racing, duels. During a duel, only 2 horses will participate in the race. In order for the race to be interesting, it is necessary to try to select 2 horses with similar strength. Write a program which, using a given number of strengths, identifies the 2 closest strengths and shows their difference with an integer. Alright. How do we do that? I'm thinking hard now. There's got to be the number of horses, the strength P1 of each horse, P1 is an integer. The difference between the 2 closest strengths. So we need some sorting. Anybody know how to sort? And we need Great, so I'm going to actually have to learn new Rust to solve this one. Input, output. What does output mean? We don't have to say what horse it is. We just have to say the difference in strength. So this really is just sorting. Okay, so we're going to have a vector. And we're going to let this be a mut vector again. Let mut and And what do I want to say it? Stirs, mutt-stirs. It's a vector of isize, because it says an integer. That's the most natural integer, equals vec new. And for each horse, we're going to pass it as an rsize, and we're going to do stirs.push pi. And now we want to sort. Sort. Gotta be a way to sort. 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 It doesn't take any parameters, this one. So I'm going to assume there's a natural ordering and just do stirs.sort. The logic here is that if we sort, every horse has to be closest to the horse with the next closest strength. And we're going to step through and iterate and check what that maximum strength is. And so we're going to start here, let mut d, because it's called d there, I'm just going to call it d here. I'm going to make the wild assumption that there's enough inputs, and I'm going to say stirs, these are strengths, 0 minus strengths 1. That's the best difference we have, and absolute, that was a .abs, wasn't it? .abs, and now we're going to say for I in start at 1 dot to n. Let next delta equal strengths I minus strengths I minus 1. Is that correct? This goes right to the last one and checks the last one, checks all of them to the previous one. No, we should check all of the next one. In which case we should start at 2. We can start at 2. Anybody know what happens if 2 is greater than? I don't know. I minus 1. And there must be a min-max function. Min? Min, 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 min. The minimum of d, comma. Actually, just do this. D, because the minimum of d. We're going to write out d. If I understood right and my Rust is correct, which it very often isn't, did you mean main using standard comp min? I say these types of warning messages in compilers are very helpful. It says, did you mean this? This one right here? Assuming it makes sense. If it doesn't make sense, it's not so helpful. And of course, an error is not satisfied, blah, blah, blah. We have vectors, stirs I, stir isize vector. What? Let's make n usize. Success! Success! Success. Okay, this I think is why they're in the easy category. There was no graphics, but we weren't here very long, so let's just submit this one. Get this over with. We go to 100%. And that one wasn't really challenging. And there's a sort function. We use sort. I remembered ABS. We have the min, and that's all you have to do. It's a little bit more complicated if you actually had to output which horse it was, which would be more interesting, to be honest. Say which horse is actually the ones. There's 2 horses. Just omitting the difference put this in really easy category. And I don't want to do 2 without graphics in a day, so I think I'm going to leave it at that. And that'll be it for my show for today. We made progress 2 levels. We finished some more. Well, in the end, we cleaned up one more easy one. We might as well finish these off at some point. Maybe 1 per show, just quickly run through them. Assuming I can quickly run through them. And the medium, as long as they keep having graphics, we're going to stay at medium. We're going to stay at medium until they run into graphics, and then we'll move to hard. And it looks like there's a lot more medium than easy ones, though. And I think we did okay today. We only had the slight issue with Marvin not being optimal, but the brain dead solution would actually work if you didn't have a time limit, as often are in these ones. And we learned some few new items for Rust. I'll probably go back later and add them to my cheat sheet just so I have a reminder for it. And I hope you enjoyed the show. I'm glad you were watching, and I'm not sure if I can go tomorrow night. Tomorrow night is my bouldering night, and my fingers are usually not in a great condition to use the keyboard after it, but I might be okay. And other than that, I have to go to Berlin this week to do a presentation, so we might not have a continuation to this show until Thursday or Friday. Sorry for the delay on that. But tomorrow I should be doing my regular Fuse show. I've not decided what I'm going to do yet, if I'm going to do serialization or just play with animation again, or just doing something entirely new, but you can tune in for that. Or otherwise, be sure to subscribe to my channel to find out, or we'll see you back at the next evening Rust to see what level we get to next. Again, thank you very much. Follow me on Twitter, subscribe to my channel. I'll upload this to YouTube later. It was fun. I think we're learning something, and we'll continue doing this with Rust. Thank you very much.